In this video, we're going to go over example 4 from our 2.8 on derivatives for limits. So example 4 says, consider the two limits from part A and E of example 1. Can either of these limits be calculated using the L'Hopital's rule? If so, do it. Okay, so let's just recall what those limits were. So our function was x squared plus 1 over x squared minus 1. Part A, we're looking at the limit as x goes to infinity, and E, the limit as x goes to 1. So I'm just going to write those down so we have them in front of us on our page here. So we're looking part A. If our paper stays put, part A is looking at the limit as x goes to infinity of x squared plus 1 over x squared minus 1. Part E was looking at the limit as x goes to 1 from the positive side of x squared plus 1 over x squared minus 1. All right, so let's look at first part A. So notice that as we get very large x's, our numerator goes to infinity and our denominator goes to infinity. So here we have the form infinity over infinity. So yes, we can use L'Hopital's rule. So that rule tells us this limit is equal to the limit as x goes to infinity of 2x plus 0 over 2x, which is just equal to, well, 2x over 2x cancels out to become 1. So it's equal to the limit as x goes to infinity of 1, which there's no x to play around with here. So that limit is actually just 1 itself. So we get 1. So now let's look at part E. So what happens in the numerator and denominator as x approaches 1 from the positive side? Well, as x approaches 1, we see that numerator just becomes 1 squared plus 1, which is 2. The denominator becomes 1 minus 1, which is 0. So here the form is 2 over 0. So we're dividing by 0 in the form, but that's not one of the forms that we have. This is not a form we can use with L'Hopital's rule. Let's look at another way we could find this limit, though. How else besides using a table? Well, what we can notice is that that numerator approaches 2. And what happens to the denominator here? So the numerator stays put at 2. I'll write this out, numerator and denominator approaches a really small number. So if we have a fixed number 2 dividing by a small number, what happens there? Well, it's as if we had like 1 over x. 1 is just fixed, dividing by x as x goes to 0. What we see is in that fraction, the output blows up. Dividing by a small number is equivalent to multiplying by the reciprocal, meaning multiplying by a huge number. So this would blow up, go to positive infinity. So how else? That was more just like a discussion of seeing, or rather using the form of the function to justify and reason why or what the value is of the limit. In general, to do problems like party, we would want to use the limit, or rather the table like we saw in example 1. Awesome. All right. Great work, everyone. Please rewatch this video or any parts of these video from section 2.8 to become more familiar using this rule. And when you're ready, practice the examples and exercises that follow here. It'll give you more opportunity to practice using this new rule that we just learned.